The last topic of the chapter is rational numbers and decimal expansion. What is the relation between rational numbers and decimal expansion? In class 9 you have already learned the decimal expansion of rational numbers can be of two types. That is terminating. The second one is non-terminating recurring. Recurring, in other words, repeating. So let me give an example. If it is terminating, I'll take the 1/5 as a rational number. So if I convert into decimal expansion, it becomes 0.2. Right? Let me take here 1/7. 1/7 comes to be 0.142857 bar. This is bar, we call this, which shows that the set of these numbers repeat again and again. So what is the property? How can I say that whether it is terminating or non-terminating recurring without just expanding all, dividing and finding that all these things? Just by seeing the number, how can I make out? So one of the theorems states that if the denominator can be written in the form of 2 raised to m into 5 raised to n, where m and n are non-negative integers. Non-negative integers. Yeah, if the denominator of the given fraction or the rational number is of the form 2 raised to m into 5 raised to n, where m and n are non-negative real numbers. Non-negative real numbers can be from 0 and non-negative integers. So 0, 1, 2, 3, 4 and so many other numbers like that. So if it is of this form only, it becomes terminating. If it is not 2 raised to m into 5 raised to n, then it comes to be this case, that is non-terminating recurring. In all other cases, only if 2 and 5 and only them are present, then it can be it can be terminating. Otherwise, maybe some other number like 3, 7, 6 or any 7 or any prime number other than 2 and 5 are present in the prime factorization of the denominator, then it comes to be non-terminating recurring. Let us go to the exercise and just see the questions. Some of the questions only. I pick up some of the questions and then just see. Some questions like this. We need to check its exercise 1.4. You need to check whether the decimal expansion is terminating or non-terminating recurring. The first one is 17/8. Just by seeing and also by my knowledge, I know that 8 can be written as 2 cube. 2 cube. That is 2 raised to 3 and 5 raised to 0. 5 raised to 0 is also a non-negative integer. So this can be a terminating. This is terminating. Next, we go to the second case. That is given to be 6/15. 6/15. I know that this is not simplified now. See, there is a common factor 3 in the numerator and the denominator that shows that it becomes 2/5. Now again, it is 5 raised to 1 into 2 raised to 0. Right? This shows that it is of the expansion 2 raised to m into 5 raised to n. This form it should be. So this is also terminating. The third one. The third question is 77/210. 77/210. Just by seeing the denominator, I can see that it is divisible by 7, and even the numerator is also divisible by 7. So I'll remove 7 from numerator and denominator. This comes to be 11/30. Again, 30 can be written as 3 into 10. 2 into 5 is 10. 3 into 2 into 5. But this is not of this form because there is one more prime factor, that is 3. That shows that it is non-terminating recurring. We go to the fourth question. The fourth question is 35 by 50. 35 by 50. I think 5 is common in the numerator and denominator. You can just see 35 is 7 times 5. 50 is 10 times 7. 10 times 5. This can be written as 2 into 5. 2 raised to 1 into 5 raised to 1. That is of the form of 2 raised to m into 5 raised to n. Hence, it becomes terminating. Next, the fifth one. And the last one as of now, that comes to be 64 by 455. 64 by 455. Till now we didn't try to do again for prime factorization because it was simple numbers. Now we'll go to do prime factorization. 455. 5 is divisible, so it comes to be 91. 91 is divisible by 7, 13. 13 into 7, 91 into 5 is 55. So this can be written as 5 into 7 into 13. But it is not of this form because there are extra prime factors, that is 7 and 13. That shows that it is non-terminating recurrent, right? Now the second part of the question is we need to find the decimal expansion. That is second question. And I have opted in a few of them instead of writing all of them. I just give you a smaller method rather than going on dividing with the long division method and finding the terminating expansion. The first one I have chosen is 23 divided by 2 cube into 5 square. 23 divided by 2 cube into 5 square. Just my mechanism to do this is 23 divided by, I need to get multiples of 10 here. So 2 cube into 5 square, I can get 100 into 1 more 2 is remaining. So in order to get a multiple or a maybe power of 10, I am just trying to multiply 5 up and down so that this I can write it as 10, and that becomes easy for me because decimal expansion has base 10. So this comes to be 1, 2, 3 zeros. 1000. 23 into 5. 3 5 is 15. 10. So this is 115. 115 divided by 1000. This is based on changing the decimal places. The point was here. We should go 3 places left. 1, 2, 3. This comes to be 0.115. Rather than simply dividing this, maybe this comes to be 8 into 25. That is 223 divided by 200. This takes a very long time, and just going on dividing makes us feeling bored. That math is not nice. Next, the second one I have chosen is 13 divided by 3125. 13 divided by 3125. This number is so big, but it is given to be terminating. That's why maybe it is only divisible by 5 because there is no 0 at the last place. So I know that 25 square, up to 25 square I have by hearted. So 25 square comes to be 625. So I can divide this. Okay, let me multiply 5 to this itself. I can check whether it is going to be one more. So 5 5s are 25, 2 5, 5 2s are 10, 12, 1, 6 5s are 30, 31, 3125. That means that it is 25 square into 5, or 5 raised to 25 is 5 square, right? This is 5 square whole square into 5. That is 5 raised to 2 into 2 is 4 plus 1. That is 5 raised to 5. We write this as 13 divided by 5 raised to 5. This much I got. So based on my simpler method when compared to the others, I need to multiply 2 raised to 5 up and 2 raised to 5 down. So down I get 1 followed by 5 zeros. 1, 2, 3, 4, 5 zeros. So 13 into 2 raised to 5. 2 raised to 5 I know that it is 32. So it comes to be 13 into 32. Right? Now I multiply by 3, this becomes 26, 0, 3, 9, 6, 1, 4, 1, 6, 4, 1, 6. How many zeros are here? Here there are 5 zeros. So I need to go 5 places to the left. That comes to be from this place 1, 2, 3, 4, 5. Here 2 more zeros. So instead of writing that, I'll write 0.00416 is the decimal expansion of this given number. Now we go into the last question of the exercise. That is question number 3 of exercise 1.4. The question is you need to find the decimal expansion of the given numbers. I'm just going to write the numbers and explain what is going to be. The first one is 43.1, 2, 3, 4, 5, 6, 7, 8, 9. The second one was 0.1201, 0.1201 to 0, 0, 1, 2, 0, 0, 0, 1, 2, 0, 0, 0, 0, and like that something. The third one is 43.1, 2, 3, 4, 5, 6, 7, 8, 9 bar. What does this bar represent? This bar represents that it is a non-terminating recurring number. That means that its denominator is not of the form 2 raised to n into 5 raised to n. So what is the question now? In each case decide whether they are rational numbers or not. So to check whether it's a rational number, it needs to be either terminating or non-terminating recurring. Here you can find that it is terminating, therefore it is rational. Here it is not terminating and it's not recurring also. See here 1, 2, 0. Here one more 0 is extra. Here one more and like that. So it is not rational. It is irrational. Seeing this, I can make out that it is non-terminating but recurring. The same number of digits appear again and again. That means that it is rational. The second part of the question states, if they are written in the P by Q form, what can you say about the prime factors of Q? P by Q form. P by Q form, what do you say about the prime factors of this? Prime factors, that is prime factorization. Prime factorization of Q says that if it is terminating, it needs to be of the form, Q needs to be also of the form 2 raised to m into 5 raised to n in this case. Yes, here Q is not of the form 2 raised to m into 5 raised to n because it is non-terminating recurring in this case, but it is terminating recurring in this case. Thank you.